right, good morning, everyone. Today is April 29th, a Wednesday, and we are on week 13 out of 18. We just took the exam, so I saw the results. For the most part, many of you guys did very well, so great job with that. For those of you guys that are struggling with the material, make sure you're getting help as soon as possible, because you're going to see this stuff again in future chapters as well as in the future exam. And the way that we tested doing the Confer live Zoom, we're probably going to continue doing that moving forward. Does anyone have any questions or thoughts or comments about the exam? Feel free to unmute yourself if you guys want to say anything.
I already messaged you, but as far as turning in the corrections, I didn't take like a picture of the ones that I got wrong. Is there a way to still access it? I know I messaged you, but.
Oh, okay. You could always access your exam by going into Alex, pressing on, you could click on your gradebook, and you click on your gradebook, you could click on your exam, and then you could press view results of your exam, and it'll print out an entire PDF of all the questions that you have on your exam, what your answers were, and what the correct answer is.
Okay, I tried that, but when I clicked on it, it didn't pop up. So I'll try it again though.
Does anyone else, how did the rest of you guys access your results?
How I did it is I go on Alex, I go to gradebook, where say exam 4, you have to click where the percent you got on your exam, and that's how it accessed your test.
Okay, thank you.
You're welcome.
Great.
Yeah, that worked for me too. You click on the link of the percent there, and it brings up the questions and answers that you did.
Great. Good question. Any other questions or any other comments? Did you guys like that type of exam style or not like it? No thoughts? Alrighty. So today I didn't have a time to do a PowerPoint of the announcements, so I'll just talk through the announcements. Today we're going to go through the class worksheet on functions and exponentials. So this right here, I posted this on our class files in Canvas, so you should be able to find it there. It comes with the answers and with the problems as well. As you can see, there's 13 questions. I'm going to try my best to get through all of them today so that it could be due on Sunday, but let's see how far we get. I'm going to try my best to get through all 13. And today we also have 2 group presentations. I believe it's group 6. Is group 6 here? Or those who are presenting?
You mean group 6, not for Math 140, right? Because
they're both the same.
Oh, we presented last week.
Oh, I'm sorry, group 7, that's what I meant. It's group 7 here. Okay, if not, then I'm just gonna move forward.
I'm here from group 7, Ms. Mahan.
Okay,
I think Victor's here.
Yeah,
this is Melissa Monterrubio. I think Victor's also here, but I just don't see Katya and Anthony, because it's me, Victor, Katya, and Anthony for group number 7, Math 130.
Okay. All right, so, okay, so if you could maybe just message them or something, just to make sure that after our break that they'll come back and we'll do the presentation.
Got it. I'll send them a message. Thank you, instructor.
Melissa, is Math 140 group 7 here? Nope, okay. So depending on time, we'll also do spotlights. And I know, Melissa, you said you wanted to do your spotlight today. So let's see if we have time. If we have time, I'll have you do that. Alrighty, so without further ado, there's no other questions. We are going to move forward with the video or the worksheet for today. If you don't have the worksheet printed out, that's okay. You could just take notes on your own sheet of paper. So in this chapter, I think this is chapter 9, I believe, for Math 140, and chapter 7. I forgot what the number of the chapter is for each class. But this section now is on functions. Is on functions and exponentials. So we're going to dive deeper into functions and exponentials. We've done functions before. Exponentials, we've done exponents before, but we have not done exponentials. So The reason why we're going to talk about exponentials is the chapter after this. In the future, in the next chapter, we're going to talk about logarithms. So when we talk about logs, you're gonna have to need to understand exponentials in order for us to talk about logs. All right, and just a review of functions. When we talk about functions, if you remember that picture that I drew before, it's like a spigot, it's like a machine, right? And when we talk about functions, whatever comes in, when you have an input, the thing that goes into the function, and whatever goes out is called the output. There's an input and there's an output. And normally functions are normally named with the letter F, but of course it could be named the letter G, H, it could be named any letter. And how you write the function, the notation of it is that you put parentheses, and then inside here you put the input. So you put F input, and the function will be defined as something. It'll be equal to something, because the point of a machine is that you put something in and out spits something out. So for an example, with a different color pen or pencil here, oh, that's the same color. If I gave you the number 2 as the input, and say the function is defined as f of x is equal to x plus 1, that means that the input, which is also called the letter x, the input is the x, and you put 2 inside the function, and the function will do something to that. So 2 plus 1, so it's going to do f of 2 is equal to 2 plus 1. So it takes in the 2. So again, this does not mean multiplication, right? It means that the input is 2, so you put 2 wherever you saw your input, 2 plus 1. The output is going to be 3. And normally the output is what we call y. Y is equal to 3, or we could say f of 2 is equal to 3. Meaning when you put 2 into the function, you spit out the number 3. All right, so that's a review of functions. So now in this section here, what we're going to be learning how to do is we're going to talk about how to translate functions. And for those of you guys that will be going into the next class, which is Math 45, which is college algebra, you're going to be doing a lot of translation of functions. Or those of you guys who are in STEM majors, when you get into pre-calculus, you do a lot of translation of functions as well. So what it means to translate functions means to move a function. And you can move it left, up, down, left, or right. So we're moving a function, or when we say we're moving it, we're going to move the graph, because a function can be graphed, right? That's one of the things I like about mathematics. You can always visualize what a function looks like. So here, let's start off with example. So let's start off with a function that looks like this. And based on the previous chapter that we just had a quiz on, this is called a parabola, right? And we know that a parabola is a quadratic equation. So in which the highest exponent is 2. So here, this parabola, this is kind of in its home format. This parabola is y is equal to x squared. So this parabola here is y is equal to x squared. When it's at the origin here, it's y is equal to x squared, right? So it just looks like a happy face right at the origin, or right at 0, 0. Y is equal to x squared. So now, in this example, if I ask you, if I say below is the graph of y is equal to x squared, and then I say to go ahead and translate it to make the graph of y is equal to x plus 3 squared. So they're asking me to change this graph so that the graph will become this equation. So without having to regraph the whole thing, and we've learned in the previous chapter that we could use the vertex form or the standard form of a parabola or quadratic equation, and that formula a times x minus h squared plus ka, where Hong Kong is a vertex and all that stuff. Instead of doing that, that's kind of the long way actually of do it. What you can do is you can start with its original format, which is y is equal to x squared right here. And notice that this is a form of that. And what the difference between this graph or this equation is that there's plus 3, it's inside of here, right? Instead of x, it's going to be x plus 3. So what happens with the graph then? So the long way of doing it is that we could use that formula that we learned in the last chapter to graph it, or we could plot points. Remember, you find the vertex and you plot points and all that jazz. The shortcut is going to be a formula that we're going to be using. So the formula that we're going to be using, not a formula. So if we start off with y, if we start with y is equal to x squared, if we want to translate it, if we have y is equal to, so if I'm going to say x plus h squared, where h is just a number, right? H is a number. How that's going to affect the graph is you are going to move the graph to the left h units. So if it's plus h, you're going to move the graph horizontally to the left h. So that's one of the key things. And I could derive this for you by showing you guys the long way, and then here's a shortcut. But just for the sake of time, because we have 13 topics to cover, I'm just going to tell you what it is. There's times where I actually derive things and show you guys how something is given. And then there's times where I just where I just tell you this is the end result. So if this is x plus 3 squared, what am I going to do to translate this graph? So anyone can speak up at this point.
Move it 3 units to the left.
Exactly. Thank you, Melanie. So move this 3 units to the left because this is 3. The h is 3. So if I move this 3 units to the left, I go 1, 2, 3. Move it 3 units to the left. So this vertex now is moved to the left here. This point here, so if I took every point and moved it to the left, then it'll end up looking like this. Something like this, right? Not exact, but when you do it on Alex, you'll be able to move 3 things to the left and then connect the dots. It'll make this happy face that's shifted to the left. Right? Now, that's 3 units to the left. Does anyone have any questions on that? Okay, what do you think would happen if it was x minus h squared? What would I do? Any guesses?
Would it be move 3 units to the right?
Great. Move the graph to the right h many units. So move the graph to the right. Now, let's make this a little bit different. Let's go ahead and look at your, let's look at your problem on here, on question number 1. So question number 1 in yours says y goes to x squared, and then y is equal to x squared plus 2. Can you guys see that, or is it too small?
Yeah, we can see it, instructor.
Okay. All right, so when you have something like this, so notice that the plus 2 now is not inside, it's not affecting the x, right? It's not inside here. The plus 2 is after the y is equal to x squared. So when you have something that is after that, it's going to be affecting the y value. So notice in this problem here, the problem that I just did earlier, when I put +3, it was affecting the input, right? It was affecting the x values. The input, x plus 3, now is adjusted horizontally. However, when you have something where it's not affecting the input x plus x, the input x, it's affecting the output, which is y, then we're going to be moving things vertically instead because affecting the y. So here, if I have y is equal to x squared plus h, so here, this h value, the value that I'm now adding on, is now not affecting the input, but it's actually affecting the output overall. So it's affecting the y value. So here, we're going to say that we're going to move the graph. Any guesses? If it's going to affect the y value, which direction do you think the graph will shift?
To the
Left or
left.
right, up or down?
Up or
Up.
down?
Down?
Yeah. It'll be affecting it vertically, and the question is it up or is it down? And in this case, we think it's down because these were the opposite, right? Plus h, you move to the left, minus h, you move to the right. It's kind of the opposite. But in this case, when you're talking about the output, plus h is actually going to move the graph up. So we're going to move it up h units. Oops, sorry. Conversely, if I said y is equal to x squared minus h, we're going to move the graph. What direction do you guys think?
Down.
Down, right? We're going to move it down h units. So this is the overall shebang of translating a parabola when it's in standard form. When it's in standard form, or y goes to x squared, and it's the origin, this is how you can move things in a quicker and faster way than having to use that formula that we did in the previous chapter about the vertex form and or the regular form. So here in this problem, knowing what we know, go ahead and graph that. Let me give you guys a chance to do that. Okay, so and at this point, if any of you guys have a picture of what that graph looks like, go ahead and speak up, and then I'll go ahead and highlight your video so we can see what you did. Anyone get an answer?
It's just 0, 2, right?
It's, say again?
Oh, 0, 2 as the vertex?
Try again.
Okay.
You're
I
close.
got -2 for the vertex x.
The
X
vertex
is
will be what? Say again?
X is -2. It goes.
Oh, you know, I'm actually on the wrong, I'm looking at my sheet, not yours. Just kidding. I'm looking at the wrong version. Oh, you're right. It is 0, 2. I was totally looking at the wrong version. Right. So thank you, Alexis and Melanie. Yes. So the vertex will now be at 0, 2, right? Because we shifted 2 units up. So shift 2 units up because it's affecting the y, right? So here, when you shift it 2 units up, every single point is also shifted 2 units up. So if you did this on Alex, you'll be able to probably do this a lot better than how I do it. Actually, I think I changed the width of it, so maybe that's not exactly accurate. So let me actually get yeah, actually, here it is. So the answer here, 0, 2, it looks like that, right? Kind of like what I drew. And the big thing is you just shift it 2 units up and then you draw the exact same parabola. Okay, is everyone okay with that, shifting? All right, nice work. Now let's go ahead and let's practice other shifts. So let's look at this. Now we're given a function in question number 2. If the graph is translated vertically upward by 6 units, it becomes a graph of a function g. Find the expression for g. So now we want to say, what is g of x? G of x is equal to something. Well, if you're vertically moving it 6 units up, what do you do with this function to move this 6 units up?
Add 6.
Add 6, great. And why do you add 6? How did you know?
Because it's moving upwards.
Great, because you're moving upwards, right? So based on, great job. I have so many papers here. So based on what we just wrote up here, that if you want to move something upwards, then you add an h to it. So you add that amount. So go ahead and add 6. So g of x is going to be negative 2x squared minus 3, and then you're going to add 6. So if you're going to add 6, what does g of x become? Go ahead and simplify that. We get negative 2x squared plus 3. Okay. So once you add the 6, go ahead and simplify that. Let me give you another example that's not on your sheet, just so that you could get more practice. What if I told you so what if the example is this? So what if I said h of x is equal to negative x squared minus 1, and then I say that if h is translated vertically downward by 5 units, it becomes g of x. Find g of x. So same question as what you just did, except with the different problems, different function. So let me give you a chance to work on that. If h is translated vertically downward by 5 units, it becomes g of x. Find g of x. Let me give you a chance to work on that. Hey, did anyone get an answer? Shouldn't take too long.
Minus x squared minus 6.
Okay. So g of x is equal to minus x squared minus 6. Do you guys all agree? Anyone not agree? And how did you get that, Melanie?
I subtracted 5
Great.
because it's going downwards to
Great.
minus x squared minus 1.
Great, good job. So Melanie subtracted 5 since it's going downwards. So you subtract 5 from here, you get minus 6. Okay, not too bad, right? Is everyone okay so far? Any questions? All right, moving on. Let's look at question number 3. So here, the question number 3 says that the graph of f in blue, which you can't tell it's in blue because it's black and white, but here's a graph of f, which is in blue, is translated a whole number of units, meaning that's not a fraction, that's going to be translated some whole number horizontally and vertically. So you're going to be doing both to obtain the graph of h in red. And here's the graph of h. So as you can see, the graph of f shifted horizontally and vertically to become h. So the function f is written as f of x is equal to x squared. So this is the blue graph. Write down the expression for h. So knowing what you guys now know now, knowing what you guys now know now, go ahead and try that. This is a little bit trickier. There's a shift that went down and there's a shift that went left. So how do you shift something down and left? I'm going to put you guys in what do you call it? Breakout sessions for you guys to discuss this with your group. And Garrett and I will be in one of the breakout sessions. Alrighty, that was fun. Does anyone have any questions on that problem? I was in breakout session 1. How about breakout session 2? Were you guys able to come up with an answer?
Yeah, a few of them got something.
Okay, does anyone want to show what you guys got or explain what you guys got? Anyone in breakout session 2, what did you guys end up getting as an answer?
Instructor, I got x plus 3 squared minus 2.
X plus 3 squared minus 2. Great. And that is correct. Let me spotlight my video real quick. So here is what we did in breakout session number 1. Y equals to x plus 3 squared minus 2. Great. Would anyone like to explain on video so that those who are missing class right now can understand how we got that? Anyone in breakout session 1 or 2 want to explain how we got that answer? Or Garrett, do you want to explain? Just so people could hear a different voice besides mine.
Come on, guys, don't be shy.
I heard you guys in the breakout sessions.
So can you go back to the notes that we have?
Sure.
So in this graph, it's moving to the left by 3, right? And so that means we're going to have an x plus 3 squared because we're going to the left 3. And so that lines up with that first rule that she has. And then because we're moving down, that lines up with the fourth one there. We're going to subtract the 2 because we're going down 2 units. And so the outside kind of follows our intuition of moving up is positive and moving down is negative. But then on the inside, their intuition is kind of backwards, right? Because now we're moving to the left, but it's going to be a positive 3.
Great. Great explanation.
And I have a suggestion. Showing this in Desmos, I think really helps. But maybe I can do that once you're done going through it and I can pull it up on my computer.
That would be great. Yeah, that would be great if you do. You could share your screen and do that. Let me know when you're ready. Feel free.
Okay.
Noemi also pointed out something. She said, hey, looking at this, remembering what we did in our previous chapter, this is in the vertex form of a parabola. And hey, do you remember Hong Kong? Hong is going to be -3 and Kong is going to be -2. -3, -2. What do you know? Look at this. The vertex is at -3, -2. So follows that Hong Kong, the HK version that we did in the previous chapter. So she was able to recall what we did before and tie it back to this. All right, any other questions on this? And Garrett, whenever you want to pull up the Desmos, feel free. I think that'd be a great visualization. In the meantime, I'm going to move on to question 4. So question 4 here says, suppose that the functions R and S are defined. So here's the R function, gives you something, something. Here's the S function that gives you something, something. And here they say to find R, and then that dot there means multiplication. So this is to multiply. So when you see something that says R times S and then X, so you might look at all these letters, you're like, oh my gosh, what are all these letters? What's going on here? Oops, sorry. This means multiplication. And it's a shorthand way of really writing. This is exactly the same thing as writing this. If you kind of distribute it, if you kind of think of it as distribution, it's R of X multiplied by S of X. So the way that they write this is the same exact thing as saying, take the R function and multiply it by the S function. So in other words, take this function and multiply it with this. In other words, you're going to be doing x minus 1 times 4x plus 3. So you're going to be taking the R function and multiplying it with the S function. And let me just double check if they want you to simplify that in terms of the answer. On Alex, question number 4, where are you? Yeah, so you're going to want to multiply this. So once you do this, then go ahead and FOIL it and multiply it, right? This means to subtract. So when you have the subtraction sign, when you have R minus S of X, that's another way of writing that is just to simply write R of X minus S of X. So in other words, subtract the two. So if you subtract the two, R is going to be X minus 1 minus S, which is 4X plus 3. Last but not least is when they have this one here. So you see an addition sign right there. So if you have R plus S and here's negative 2, what it means is that you're going to take the R value and plug the negative 2 inside of it. Plus, since this is an adding sign, you're going to take the S value and plug in the negative 2 in it. And then you're going to spit out an answer. So you're going to look at the R, plug in the negative 2 and get something, something. Look at the S, plug in the negative 2, get something, something, and then add those two functions together. So let me give you guys a chance to go ahead and work on these 3. So there's A, B, and C. I kind of did most of the work for you right now, but let me give you guys a chance to do that. I'm going to put this on pause and again, put you guys in breakout rooms to discuss your answers. All right, welcome back, everybody. So for breakout room one, we were able to do the 3 problems. So I did ask for a few volunteers to explain what they did. So, well, part A, I did most of the work for part A already in terms of writing out what you need to multiply. So after you FOIL it, the answer should be 4x squared minus x minus 3. After you FOIL it, 4x squared minus x minus 3. And then part B, Jennifer is going to explain part B.
So basically she foiled it for us as well. So it's gonna be parentheses 2, x minus 1, parentheses, you subtract, and then you parentheses 4x plus 3. And then you have to distribute the subtractions to 4x plus 3 will give you negative 4x minus 3. And then you combine like terms, which would be x and negative 4x. You will end up with negative 3x, and then combine negative 1 and negative 3, and you will end up with negative 4. So your answer will be negative 3x minus 4.
Great. And just a quick correction. I know, Jennifer, you said FOIL, but it's actually not FOIL. We're actually just, there's no support.
Oh,
yeah. Great. Great. Any breakout session 2, do you guys have any questions on part B? Do you guys all get that? Okay, so the big trick or the big hurdle that we need to remember is to distribute the negative through the parentheses so that we get negative 3x minus 4. And of course, if you write negative 4 minus 3x, that's A-okay as well.
I also wanted to, you did it here in your example. I wanted to emphasize that when you do substitute in like the equation, make sure you put it in parentheses like she has done here.
Good point, Jared.
And x minus 1 in the parentheses around 4x plus 3.
Great.
And then you notice in her next example, she does the same thing with brackets, which is the same thing as parentheses.
Right. Good point, Garrett. So yeah, making sure to put parentheses. Otherwise, if you don't, you forget to distribute the minus sign or you forget to do things.
Right.
Great point. And Anthony, can you go ahead and do part C or explain part C?
So since we have to add, we have to substitute -2 into R and into S, we get -2 minus 1 plus brackets 4 parentheses -2 plus 3 brackets. And we get -3 on the left side and -5 on the right side. And then it would equal -8.
Great. Does anyone in breakout session 2 or 1 have any questions about part C, what Anthony just explained? Right, so make sure you plug in the -2, first one, -2 into the second one, and then you add them up. Alrighty, very nice work. Any questions at all? All right, moving forward. So let's look at question number 6. So question number 6 is pretty similar, except now, sorry, let me.
Before we move ahead, can I show the Desmos?
Oh yeah, Garrett, go for it.
Okay, let me share my screen.
So Garrett's gonna share Desmo, which is a free website that helps you to visually graph things.
Really awesome. I suggest using it. So yeah, desmos.com up here if you look at it. But yeah, so here, g of x equals f of x minus h. This is like combining the two things that you're showing, the shifting to the right and left, right, the horizontal shift and the vertical shift. So here, if I plug in x squared, right, you can notice here the k is going to move it up and down, and the h is going to move it left and right. And this is the same thing if I were to plot, let's say, h of x equals x minus h squared, oops, on the outside, plus k. Oh, it doesn't like that. You notice here, you can't really see them, but these in fact are the same equation. If you see the black and the red changing. So this is the vertex form of a parabola, is just the translation of f of x. So they are exactly the same. You notice here the h and the k's are the same, the vertex is the same, right?
Right.
Yeah. But yeah, I suggest using this website if you ever want to graph something or you just want to see it visually and help you. I love this website. I pull this up for my own homework all the time.
Very cool. Yeah, and that's a really great visualization. So in case you have never seen this before, like if you looked at the left-hand corner of what Garrett is doing, that little blue mark tells you that's the blue graph. The red mark tells you that's a red graph. The black mark tells you it's a red graph. So you can see the difference. And then as you adjust K's and H's, the Hong and the Kong, the vertex, you can see it shifts things up, down, left, or right. So with that, it's a kind of a fun and fast way of visualizing the shifts.
Eventually we'll do something like this. And that's gonna do this to it.
And that'll make the graph skinny or fat, right?
I think we did this a little bit with parabolas, didn't we? Or no, not yet.
Yeah, we talked about it, that the A tells you whether it's a happy face or a sad face.
Right.
But we didn't really talk about, yeah.
So you can see that when it gets to the negative, it goes down. When it goes positive, it's up. But yeah, and then just like the magnitude of it kind of makes it skinnier or fatter.
Right. That's really cool.
And this is true for any function. Say I do some weird function like sine of x. You can notice that here, if I move it up and down, side to side, and then make it skinny or fat.
Right. Yeah, it doesn't have to just be a parabola. It could be any function, right? If you add a k value, I called it h in my notes, but I should have called it k. If you add a k value, always go up or down no matter what the function is. Right? And then the h value, as you can see, goes left and right. And the a value makes it wider or narrower.
Yep, I just want to show you guys that.
Very cool. Thank you, Garrett. Thank you. Alrighty, now let's go ahead and look at this here. This is problem number 5. And problem number 5 here, it's similar to problem number 4, except now G divided by H. So this is division. So with division now, when you have G divided by H of 6, same thing as what we did earlier, this is exactly the same thing as writing as G of 6 divided by H of 6. So you plug the 6 into the G function, the 6 into the H function, and you divide it, right? So, and then the last question says, or part B says, find all values that are not in the domain. So again, whenever you have a fraction, you have to be really careful of what values are in the domain and not in the domain, because fractions cannot have 0 in the denominator. So again, fractions cannot have 0 in the denominator. So the same story over and over again since day 1, right? Same rules. Again, I love math because it is so consistent. It doesn't change just because things get easier or harder. So let's just do this real quick together. G of 6. What happens if you plug 6 into the G function? What do we get? Anybody at all? I'm sorry?
6 minus 1, so it's going to be 5.
Great. So G of 6 is 6 minus 1, which is going to give us 5. Perfect. Thank you. And what happens if you plug the 6 into the H function?
Seven plus, I mean 6 plus 1, and then parentheses 6 minus 5.
Okay. So 6 plus 1, parentheses 6 minus 5. And what does that give us? 6 plus 1 is 7.
7 times 1.
7 times 1, which would give us just 7. Great. So the bottom is just 7. That's it, right? Not too bad. All right. Now it says if there's more than one value separate. Okay, now find all values that are not in the domain of G of H. So here, G of H in the domain, not in the domain of G of H. So G over H, G is x minus 1, right? That's my G function. My H function is x plus 1 times x minus 5, right? So this function G of H is going to be this. Well, we know that we cannot have a 0 in the denominator, like I just wrote up here. If we cannot have a 0 in the denominator, what can the denominator, if we can't have the denominator equal to 0, that's what I meant to say. If the denominator cannot equal to 0, what numbers will make this equal to 0? Those are eyeballs.
Would it be 5 and negative 1?
Great. And how did you get 5 and negative 1?
Don't you set x plus 1 equal to 0 and x minus 5 equal to 0?
Right, right. Well, first of all, we set the whole equation equal to 0, or the whole denominator equal to 0. So what values will make this equal to 0? Well, this is called the zero product property, right? These are factors. So because they're factors, like you said, Anthony, you set each factor equal to 0, and therefore x is equal to negative 1 and x is equal to 5. So if you want to check, if you plug negative 1 in here, you get 0. If you get 5 in here, you get 0. So any number times 0 will always give us 0. So find all values that are not in the domain. Well, not in the domain are x is equal to negative 1 and x is equal to 5. Those are the numbers that you cannot have in this function. Otherwise, you're going to have a 0 in the denominator. So whenever we get fractions, it's always common practice to make sure that we what do you call it? That we find out what the domains are. All right, so now we're going to look at question number 6. So question number 6 and 7 are pretty, they're more challenging questions. They're not adding, subtracting, multiplying, dividing anymore. Now they have this strange circle. And it looks like multiplication, but it's like a circle with, it's not a dot, it's a circle. And we're like, what the heck is that? I've never seen that before. And that is what we call a composite function. So that's going to be new. And again, if you go into college algebra or pre-calculus or calculus, you're going to see composite functions. So this is a, if we've talked about mathematics as a verb, and we talk about, or if we talk about mathematics as English, when we say adding, subtracting, multiplying, dividing are verbs, that's what you do to numbers and functions. Composite is also another verb. It's something you do to it. So I'm going to make some new notes on composite functions. So it's something that we have not yet seen before. So composite functions is really a function.
Professor, it's focused on your face, not your hands.
Oh, it is? Oh, let's try this again. Spotlight.
There you go.
Is that better? Okay, thank you. So composite functions are functions with a function within a function. Thanks for letting me know, Garrett. So it's a function within a function. So I kind of think of it as something within something else. So kind of like an alien or something, but I kind of think of it as someone that's being pregnant, right? So a woman that's pregnant, right? That's her stomach. Such a bad drawer I am. There's her legs. So inside of her is the baby, right? So a composite function is kind of like a baby living inside a mother. It's a function within a function. So what we have is we have the outer function and we have the inner function. So the outer function is on the outside because it's called the outer function. And then the inner function is on the inner side because it's the inner function. So it's kind of like this is the mama and this is the baby, right? So mama and the baby living inside the function. Now, how we write it is going to be like this.
I have another way to visualize it. If you're drawing your little machine boxes, if you take the output of one and stick it into the input of other, that's the way I kind of think of it, is you're feeding it through two machines now instead of just
one. That's another way of seeing it. Great, great. Maybe you could explain it after this. Let me finish this analogy and we could hear your analogy after that. That'd be great. So here, how we write it is normally like this. So if I have, this is how we would write it. We have the F, which is kind of like the mama function, the big one. And then of course, the F is carrying something inside of it. And the thing that is carrying inside is the baby function, right? The G. So we call the G, or whatever letter, I'm just giving it a letter right now. And then inside of, inside of the G is, inside the G function is there's some type of input. So some X, or it could be a number 2, a number 3, a 4, a letter, it could be whatever it is that's inside of that. And what you do first is this. So this, just letting you know, the notation for this is the same thing as if they said F composite, that thing means composite, G, that's what F composite G means. So again, this is composite. When you see that sign, this open circle, it looks like fog, F-O-G, but it's a little open circle composite. Or whenever you see composite, you could rewrite it as the F on the outside and the G on the inside. And what you do first is when we think about order of operations, we always start off with the inner parentheses first. So when you look at a problem like this, the first thing you do, first step, is to focus on the inside, the inner function. focus on the inner function and evaluate it, right? Do whatever the inner function tells you. It says g of 2, then put a 2 in there and figure out what that is. And then after you find out what that is, then the second step, so focus on the inner function, and the second step is to feed the outer function. Feed the outer function. I think outer only has one T. Feed the outer function with the inner function result. So when I think of my analogy of a pregnant woman, right? Whenever anyone looks at a pregnant woman, they never say anything about the woman. They always say, oh, the baby, oh, you're pregnant. So they don't even see the mom, right? For some reason, when I was pregnant, when I had a baby, I kind of lost my identity as a mother, and everyone just focused on the baby, which is fine because the baby's a lot cuter, right? So the first step is always focus on the baby, focus on the inner function. And it's, oh, what a cute baby. And here's a toy for the baby to play with, or here's something to feed the baby, right? So you focus on the baby and you feed it whatever it's asking for, or you give it whatever it's asking for. And then after the baby's happy and finish with whatever he or she is doing, then you focus on the mother, on the outer function, and then whatever you gave whatever happened to the baby, you give that to the mother. My weird way. I actually thought of the analogy when I was pregnant, so that's probably why. Let me do an example with that, and then I'm gonna have, and then Garrett, maybe you do your example for those of you that do not relate to a pregnant woman example. All right, so let's look at question number 6 here. So example 6, in your word problem, in your worksheet, is P of X is equal to x squared plus 6, and Q of X is equal to the square root of x plus 9. Two different functions, right? So a P and a Q. So part A asks us for Q composite P with an input of 7. Q composite P with an input of 7. So I'm going to rewrite this in a way where I can see the outer and inner. So the first one is always the outer function, and the second one is always the inner function. So when I rewrite this, I write the Q on the outside, and then inside is going to be the baby, the inner function, which is P. And what does the inner baby eat? The inner baby eats the 7, right? The 7 is the input for the P. Any questions so far? So I'm given this. It says find Q composite P, parentheses 7. So I rewrite it in a way that I can understand it, where I have Q on the outside and then P on the inside. So now thinking of the analogy that I had, or whatever analogy you have that helps you to remember it, and Garrett will share another analogy with you guys later, I focus on the inner function. I focus on the baby. Right? So the inner function, so who cares about the mama? We don't see mama. Mama's invisible because she has a baby. We look at the baby and we say, okay, the baby, what does the baby want? The baby wants a 7. The 7 is going to be given to the baby, 7, P of 7. So when I look at P, I'm going to put a 7 inside of it. So here, P of 7 is going to be 7 squared plus 6, right? 7 squared plus 6, because I put a 7 inside the baby. 7 squared plus 6 is going to be 49 plus 6, which gives me 1, 2, 3, 4, 5, 6, 55. Yes, I count with my fingers still. So here, P of 7 is 55. So the baby has now become 55. So if I rewrite this, I have, just to rewrite this, I have Q, and now inside of Q is 55. Because that's what the baby became. P of 7 now became 55. So now I'm done with that. Now I look at the mama function. I say, okay, mama, we're ready to look at you now. We know you're important too. So mama, what do you get? You get a 55. So plug in the 55 as an input into the mama function. So when you do that, we end up getting the square root, put 55 in here, 55 plus 9, 5, 6, 7, 8, 9. That gives me square root
64.
of 64.
No, 64. I was saying.
Is that right? Yeah.
Yeah.
64 will give me 8. And that becomes my answer. Is everyone okay with that? I know I might have gone a little bit fast on that. The overall thing is whichever one goes first is considered the outer function. The second part of the composite function is considered the inner function. And what you do first is you evaluate the inner function first. So the inner function, whatever they give you, here they give you a 7, they might have given you an X, they might have given you a 2, might have given you something. Whatever they give you, go ahead and evaluate the inner function first. Once you have an answer for the inner function, then you feed that inner function into the outer function. So whatever the inner function is, now you apply it to the outer. And again, same story with the order of operations. You work within the smallest parentheses first, and then you move outwards. Or in terms of a pregnant woman, you focus on the baby, the inside first, and then after you feed the baby, then you look at the mama and feed the mama, right? All right, and at this point, I'm gonna have you guys go ahead and try part B. So part B here, I just did part A. I want you guys to go ahead and try part B where we reverse which one's the inner and the outer function. So P composite Q, still with an input of 7, but the P now goes first. P and then Q. So I'm gonna go ahead and put this on pause, and then I'll put you guys in break rooms in a little bit. All right, at this point, Jennifer is going to explain how she got 22.
So basically, we're going to focus on the inner function, which is going to be P parentheses Q, and then the composite is going to be 7, right?
So P parentheses and then Q, good. And then the input will be 7.
Yeah. Oh yeah, input, sorry. So then since you're focusing on the inner function, which is going to be Q, you're going to plug in the input, which is 7, to the square root 7 plus 9.
Okay.
And that will give you a square root of 16, which will equal to 4.
Great.
Once you have the 4, you're going to focus on the output, which is P. And it's x squared plus 6, but you're going to plug in the 4x.
Actually, sorry, let me pause you real quick, Jennifer. Does anyone have any questions with doing the inner function to get 4? Any questions? All right, sorry to interrupt. Go ahead, Jennifer.
So it's 4 squared plus 6,
Okay.
which will give you 16 plus 6. And that will give you 22. So it's going to be that'll be P equals 22. This parentheses 22.
Yep.
Right?
So the answer would just be 22, right? Mm-hmm. So P composite Q of 7 is 22. Perfect. Thank you, Jennifer. Does anyone have any questions for Jennifer? Stephanie, were you okay with that? I know you had a question how she did that.
Yeah, and I figured it out now.
Okay, great. Alrighty, so that is composite functions. Garrett, do you have a screen share that you want to share how you, the other analogy you have?
Oh. Yeah, I can do that.
Go ahead.
Share my video. You guys see my screen okay? It's gonna be on my phone.
Okay, I just spotlighted your video. Go ahead.
Okay.
So aside from the analogy of the mama and baby, go ahead, Garrett.
Right, so if we have, just like she was talking about, F. Oh, let me write the other way first. And the way I'm really like focused on the language, the way this is read is f of g of x. If we rewrite it, like she's saying, f of g of x. And I like her analogy with the machines that spit out stuff. And in this case, we have two machines, right? We have a machine G and we have a machine F. And here, the machine G is going to get the input of X, right? And then the machine F is going to get the output from G. And out of this is where we're going to get F of G of X. And so we have two machines, the G machine and the F machine. And the output of G is going to go into the F.
I like that. So it's kind of like one machine on top of the other, and it's spilling into the other one.
Yeah, and I do computer programming, right? I'm going to school for computer engineering, and this is what we do a lot in coding. You have some function that performs an operation, you feed that into another function that does some operation. So it's not just math, it's used a lot elsewhere too.
Right. Computer programming, one function feeding into another function. Right.
And another, maybe a grosser way to think about it is like your body does that, right? You eat food and then it goes out and then that goes into the toilet, which does something to it and flushes it away, right? There's an example of two functions going on.
Yes, I like that. Great, thank you, Garrett. So at this point, it's 11:37. Right now, there's also number 7 that has to deal with composite functions. It's a little bit harder. So I'm going to give you guys a break. And during that break, if any of you guys want to try number 7 first, go ahead and try that. And then after we do the group presentations, we'll talk about number 7. But if any of you guys want to try number 7 first, feel free. You guys have the tools to do it, but it's just a more challenging one. So I'm going to give us a break until 11:45, so about 7-minute break. And group 7, go ahead and get set up, and I will see you guys after the break.
Professor?
Yes.
I sent you my student spotlight last night.
Okay. All right, so up next is that we have group 7 from Math 130 with Anthony, Victor, Katya, and Melissa presenting, and they have given us permission to record and share their presentation. All right, go ahead, guys.
So this is systems of equations, and I'm Anthony Miranda.
I'm Victor Mejia.
I'm Katya Orozco.
And Melissa Monterrubio.
So there are 4 ways for a system of equations to be solved. A system of equations is 2 or more equations that share variables. Like I said, there are 4 ways of solving a system of equations. 1 is graphing, 2 is method of substitution, 3 is method of elimination and addition, and 4 is a system of 3 linear equations. You can go to the next slide.
When it comes to systems of equations with using graphing, you either graph or draw 2 lines for each equation, and the solution is usually where the lines intersect. There can be 3 answers that can be found. There's the x and y, which is where the lines intersect. No solution, which in number 2, it shows 2 lines that are parallel. They'll never really meet, so they never have an answer. And then there's the third one, which is many solutions. Both lines go on forever in the same direction, but are right on top of each other. You can hit the next slide. An example, I should show the example of the first one, but see the y equals 4x plus 3 is, I believe, the dark line, and y equals negative x minus 2 is the blue line. And the point that they collide on is -1, comma, -1.
And for a method of substitution, we basically just need to substitute one equation into the other equation, so we can end up with one equation. And I have an example on the right-hand side using the substitute method for 3x plus 5y equals 30. And then the second half is y equals 2x minus 7. And if I could get the next slide, please. Thank you. So basically for 3x plus 5, we would substitute that and put the 2x minus 7 parentheses equals 30. If we work out that parentheses of 2x minus 7, that equals 10x. So right below it, that's 3x plus 10x minus 35 would equal 30. And then we add 35 on each side. And then that would give us 13x equals 65. We divide 13, divide both sides by 13, then that would give us x equals 5. So that x equals 5, we would plug it in to the equation right next to it. So that would be 3 times 5 plus 5y equals 30. 3 times 5 is 15, so 15 plus 5y would equal 30. Then we minus the 15 on both sides of the equation. And then we would end up with 5y equals 15, divide that by 5, and then that would be y equals 3. That's basically how the method of substitution would work. And I also put another problem on the right-hand side. If you work that one out, your answer would basically be the 5, comma, negative 4.
If we were doing a class presentation, I'd give you the class time to do this and work it out. But unfortunately, it's not in person, but I'm glad you guys have you try.
Yes, thank you.
So the method of elimination and addition. To use the method of elimination, add two equations together so that one variable is eliminated to get one equation and one unknown variable. So the example here is 4x plus 8y equals 20. And the second equation is negative 4x plus 2y equals negative 30. So we eliminate the 4x. So we would end up with 10y equals negative 10. We divide by 10 on both sides, and y would equal negative 1. So we substitute negative 1 into the first equation, and 4x minus 8 equals 20. We add 8 to both sides, so 4x equals 28, and we get x equals 7, and y equals negative 1. We have one that you guys could try, but I'll do it with you guys because not a lot of people like to volunteer. Negative x minus 7y equals negative 4 equals 14, and negative 4x minus 14y equals 28. So we're trying to get rid of the 4, the negative 4x. So we put we substitute, or we distribute negative 4 into the top. So it would be negative 4 and parentheses negative x minus 7y equals 14. And then we would subtract that from the bottom equation, and that would give us negative x minus 7 parentheses negative 2 equals 14. And then x plus 14 equals 14. And we get x equals 0 on the bottom. And then we would substitute that back in, I believe. And then 4x plus 28y equals negative 56. And then negative 4x minus 14y equals 28. and 14y over 14 equals negative 28 over 14. And we get y equals negative 2 and x equals 0.
Okay, and for this last one, you have the system of 3 linear equations. So what you have here is 3 equations and 3 unknowns, but your goal is to go to 2 equations with 2 unknowns. So right here we have the 3 equations. You choose 2 out of the 3. So the first ones I chose is 1 and 2, equation 1 and 2. And then you remove one variable. In this case, I remove the z. So then I get 3x plus 2y equals negative 5. Then down here you have equation 1 and 3. And then we also remove the z from that one, which is gives you 2x minus y equals negative 8. After that, you take those 2 equations and then you put them together. And then you solve for the last variable, which would be x in this case. And then once you have x, you plug it into the original equations. Either one works. And then for the rest of the variables, for example, y, you'd get 2, and z, you'd get 5. So I have another example with 3 equations as well, only this time the z is given. So all you have to do is plug in the z and then solve from there. You get, when you take the first 2 equations, you already have the one with the z. So you just have to plug in, oh wait. Oh, for right here, you're solving for y, which is right underneath where you plugged in z, and then you would get x. And then once you get x, you could go ahead and back into one of the original equations and plug in both z and x, which would, I plugged it into the first equation, I plugged in z and x, and then it'll give you y, which y equals 1. And that is all.
Great. And I'm gonna stop the share. Great job, you guys. Does anyone have any questions or comments for this group about their presentation? I have a question. I mean, I was actually really impressed with the PowerPoint, and especially I know like writing down math equations is sometimes a hard thing for students to do. How did you guys go about doing this?
Well, the way I did it, I just did it like by typing. I tried looking up how to do like substituting equations into slides, but it was like kind of hard for me. So I just did it normal like typing.
Oh, okay. Typing on PowerPoint?
Yeah, so like I would underline, you know how you could underline the words? I would underline the numbers and make it look like a line below it.
Okay, very nice. How about the rest of you guys?
I just, for like the last 2 slides, I just added lines on the bottom, highlighted the answer because it's a lot of work there. And then just for like the arrows and stuff, it just like the little add-ons that you could put from the slides itself.
Right.
Yeah, it does look good.
Yeah, I love, yeah, highlighting things in certain colors really makes it really clear, putting boxes around things. So the presentation is, yeah, very clear. And I liked how Victor decided to, his is more visual, his part, and he just took pictures and downloaded it in. So very cool. Any other questions or thoughts for this group?
I have a comment about systems of equations. For any of those interested in STEM majors, get very comfortable with systems of equations because they come up all the time. I don't know if you can attest to that, but I have experienced systems of equations so much.
Right. Yeah, in computer science, right?
Oh, in physics, engineering, the different math classes I've taken. Yeah, all over the place. They come up a lot. They're very applicable.
Right. Yeah, once you guys get to, if you guys go to higher math, it's when you get to college algebra, you'll learn a fourth way of doing it, which is using matrices. So, and matrices is a condensed version of what you do with substitution and elimination. And
I think you do a bit of that in 45, no?
Yeah, college algebra.
Yeah.
In math 45, you're going to be learning about matrices. Yep.
And matrices are amazing.
And that's
They're
about
weird,
solving
but they're
system
amazing.
equations. And maybe not just the three equations and 3 unknowns, but maybe 5 equations and 5 unknowns or something like that. And it's a kind of a fun, almost like a gaming way of solving it, right? So some things to look forward to. All right, well, thank you so much, Group 7. Excellent work. Because we have 30 minutes left, Hannah and Melissa, I'm going to have you guys do your spotlights next Monday, if that's okay. Next Monday or Wednesday. So that being said, I'm going to go ahead and continue on with this lecture. So here is example 7 that I had said, if you want it, you could do that over the break that we just had. Oops. And by the way, let me just make one more comment. I hear Garrett sharing about, how the things that we're learning is applicable to other subjects such as physics and computer science and different things. I just want you guys to know that math is so applicable everywhere, and we're going to be learning about exponential functions, and that's one of the things that that a lot of statisticians and mathematicians and scientists are looking at as we're dealing with this coronavirus right now. So they're looking at a lot of different models of the virus, and they're looking at the exponential growth of it. I just did a 30-minute presentation about a mathematical perspective of the coronavirus, and I just posted it up on YouTube under the Math Rocks playlist, but I also posted it on my Facebook account, and it was really for my friends and family and the general public, because I just hear such a wide spectrum of people responding to the coronavirus, like being really, really scared and being like, oh, that's nothing at all, don't worry about it at all. And everyone just responding based on different headlines, and a lot of headlines, and there's a lot of chaos going on, and there's a lot of bickering going on. So in my video, I shared a mathematical perspective that has no emotions involved, no interpretations, no you should do this, you should do that, none of that, just basic math about the fraction of how mortality rates are calculated. And from that, then people can make their own interpretations. So if you guys get a chance, go ahead and check it out. It is on my Math Rocks playlist, as well as on my Facebook page, if you guys want to check it out.
I have I'll send you a video. It's about again, the statistics of the coronavirus and just exponential growth in general, and how we're trying to, like what they were talking about with flattening the curve kind of idea.
Right, yeah, what that means, right? Right. All right, so great. So let's take a look at this real quick. Find G, composite H, and the domain. So this looks a little bit more complicated than what we've done before, but it's the same idea. So here I'm going to start off G, composite H of X. If I rewrite that, I'm going to have the G function is the outer function sitting on the outside, and the inside function is going to be H of X. And notice it's not a number, the input, but now it's just the letter X, and that's fine. So what I do is I say, okay, what is H of X? Well, H of X, I don't have to put an input. There's no number I need to put in it, right? It's just H of X. Well, H of X is X minus 4. So here, G, inside the parentheses, instead of putting H of X, I'm going to put X minus 4. And again, it's different from the previous problems because there's no number that you put in. You just put in a letter, and that letter is X. So you have X minus 4. Is everyone okay with that step? Step 1. Step 2, now let's go ahead and feed the outer function, or let's feed the mama function, right? So the mama function receives the x minus 4. This is the input for the mama function. Here's the mama function. I'm going to feed x minus 4 wherever I see the input. So here's the mama function. The input is x, but instead of putting x, I'm going to feed it with x minus 4. Like if this was the input was 2, I would put 2 in it, right? But since it's not 2, the input is x minus 4. I'm going to put x minus 4, feed that into this function, and that will become the square root of 5. Instead of the x, I'm going to have the input of x minus 4 because I'm feeding this into this machine, and then plus 30. So when I simplify this, I get 5x minus 20 plus 30 because I distribute this through. I could combine like terms, so I get square root of 5x plus 10. And therefore, that is my answer. So here my answer isn't a nice number, but it's actually another function. Is everyone okay with that? I know I kind of went through that kind of fast. I look at the inner function, which is just x minus 4. I feed the outer function. Now then I look at the outer function, and I feed the outer function with the inner function. So x minus 4, I put that into the input of the outer function, replace it, and then I simplify. And then, are there any questions actually?
Why is it the square root?
Great question. Because the mama function or the outer function has a big square root outside.
Okay.
Is that okay?
Yeah.
Good. Any other questions? Great. So now the last question says, or to the last part of this question says to find the domain. So whenever I have an absolute value, so what is the domain of the square root of 5x plus 10? So they're asking me to find the domain of the composite function. Well, the composite function is this. So what is the domain of this? So what you need to know is with radicals, when we're talking about real numbers, if I have a square root, can I have a negative inside a radical? Do you guys remember? Can I get a negative inside a square root?
No, you cannot.
You can't, right? Because if you have a negative, you have an imaginary number. So when we're dealing with real numbers, the absolute value, if you have the square root of something, if it's a square root, the inside, or the radicand, we call this the radicand, must be positive. It cannot be negative. So the inside of, or they call this the radicand, must be positive. So 5x plus 10 has to be, the domain of it has to be positive.
You got your own shit. You want to use it, use your own.
You guys, if you guys don't mind. So I'm gonna, 5x plus 10 has to be positive. Can 5x plus 10 be 0? Can you have a 0 inside a radical?
No, right?
Try it out. Plug it in into your calculator. What's the square root of 0? Do you get an error or do you get an answer?
You get 0.
You get 0, right? So you can have a 0 underneath a radical. So the square root of 0 is just 0. So it's okay for it to equal to 0. So I put it greater than or equal to. So radicand must be positive, and or 0, right? So it's okay for it to be 0. So I set the inside of the radical greater than or equal to 0 because that's the domain. The domain has to be positive or equal to 0. And now it becomes an inequality. So now solve for the inequality. So we want to know what x is. So to solve for this inequality, I subtract 10 on both sides. So I get 5x is greater than or equal to negative 10 because I subtract 10 on both sides. I divide both sides by 5 or negative 10, which one?
5.
By 5, right? We divide by the coefficient. Good. So we divide by the coefficient, meaning the number that's attached to the 5 or attached to the x. 5 divided by 5 is just x on that side. And this negative 10 divided by 5 is negative 2. So now we know that the domain has to be greater than or equal to negative 2. So I can plug in any number. If I plug negative 2 in here, I get negative 10 plus 10, which is 0. Square root of 0 is A-OK. If I plug in a number greater than negative 2, say negative 1, I get negative 5 plus 10 is positive 5, which is A-OK. So any number that's bigger than negative 2, I'll get a positive radicand. If I plug a number less than negative 2, say negative 3, I get negative 15 plus 10, which would give me a negative 5, which is not okay. So we need to have something that's positive in there. So notice that this question says to use interval notation, number 7. So to write this in interval notation, does anyone know how to write this in interval notation? So if I have a graph, I have negative 2 here. Just x is bigger than negative 2. So I'm going to have a solid dot on negative 2, and I'm going to go to the right because it's bigger. So now when I want to write this as an interval notation in terms of a window, what's the left-hand side of this blue line?
Wouldn't it be positive infinity?
So, right, so this is going to positive infinity. What's the left-hand side of this blue line?
Would be a closed bracket.
Right, yeah. A closed bracket on negative 2. Good. So closed bracket on negative 2, and positive infinity gets a what?
Open bracket.
Open bracket.
Bracket, right. So this is the interval notation of this answer, for this answer. Is everyone okay with that? Any questions? No questions? All right, so without further ado, I'm going to move on to another topic now called one-to-one functions. Determine where something is one-to-one or not. All right, so if you recall, in a previous chapter, we use the vertical line test. In a previous chapter, we used the vertical line test to determine if a graph is a function or not. Right? Do you guys remember that? Where we had questions on a test where I would give you, I give you a bunch of graphs, and I say, is this a function, yes or no? And then we talked about if function is something with for every input, there's a unique output. In other words, for every x, there's exactly one y to it. And in other words, when we draw a vertical line, that the vertical line only touches it at one point. And if it touches it at one point, you say, yes, it's a function. And if it touches it twice, then you would say, no, not a function, right? And here, if you do it here, even with dots, if you only touch it once, then you would say, yes, function. Do you guys remember that?
So would this be the horizontal line test?
Exactly. So here in this chapter, now we want to know if a function is what we called one-to-one. I'm going to say if a function is one-to-one, okay? Or if a graph is one-to-one. Here, now we want to know if a graph is one-to-one. And to determine that, we use the horizontal line test. So The horizontal line test is the opposite, right? Now we're going to draw horizontal lines to figure out whether it's the word one-to-one or not. And right now, just for the sake of time, I'm just going to say, let's use a horizontal line test. And then I'm going to explain to you guys later when we talk about exponentials and log functions, what is one-to-one, right? So looking at a graph, for now, what is one-to-one is that if you draw a horizontal line, if it touches it at more than 1 point, then it is not one-to-one. So for an example, here in these pictures above, if I drew a horizontal line, this would be considered, touched it twice, this is not one-to-one. This here is not one-to-one, right? In the pictures that I just drew here. So now it's the reverse. It's saying that for every output that there's exactly one input. So one-to-one means that for every output, there is exactly one input. Whereas when we were talking about functions, we were saying for every input, there was exactly one output. So here it's the reverse. So for every y value, there should be just one x value. But here, if you look at this y value here, there's two x values associated to it, and that's why it's considered not one-to-one. So let's go ahead and look at some graphs here. Is this one-to-one? Draw a horizontal line. Yes or no?
Yes.
How many times did it touch the graph?
Once.
Once, yeah. So if it just touched it once, then the answer would be yes. So here, the horizontal line test. The horizontal line test says that the graph is one-to-one if it touches the horizontal line test just once. Just once. So that for every y value, there's only one x value, in other words. So when you draw the horizontal line, it only touched it once. Is that okay? So let's go ahead and look at this one. If I drew lines here, line, okay, that passed it, it's okay. This is okay. It passed an empty circle, so just touch it. Is this considered one-to-one?
No.
Why not?
Because they'll pass 2 times.
Where does it pass 2 times?
Oh, no, I thought we were talking about the third.
Oh, okay, yeah, sorry, just on the second one, right? So this one would be?
It would be one-to-one, right?
Yeah, it is, yes, because the graph only touches the horizontal line just once. Right? And then I think you were talking about part 3, the third one. The answer is?
No.
No.
No, because how many times does it touch the graph?
Twice.
Twice. Great. How about this one, the fourth one? Let's go ahead and draw lines. Yes or no?
Yes.
Yes. Even though there's 4 dots, when you draw horizontal lines, those 4 dots only touches it at 1 point. This one got cut off, the last one here. So if I drew one, it got cut off to this page here. So I see dots here, drawing horizontal lines. Is this yes or no?
No.
And why not?
Because that one touches 3 times.
Great. Because there's one line that touches it 3 times, right? Even though the other lines only touches it once, as long as one line touches it more than once, the answer would be no. Last but not least, this is actually a cosine curve, I think. Yes or no?
No.
No, right? Touches it at multiple times. Is everyone okay with one-to-one?
Yeah, that one's cosine, by the way.
I'm sorry?
It is cosine.
Oh, it is cosine, yeah. Like I think it is. All right, now number 9 to 13. You know what? Because I don't like to rush through things, I'm gonna hold off on doing 9 to 13. So let's say this. I am going to, because we didn't finish this is what I'm gonna say now. I'm gonna say that do as much of this chapter as possible. So, and I would say at least 8 topics, because we finished 8 topics. Do as much of this chapter as possible, at least 8 topics by Sunday night. And then on Zoom on Monday, I'm going to finish the last 5 topics in lecture. And then I will say that this chapter, I'll have the whole chapter, entire chapter due by Monday night. So that way, by Monday, you only have 5 topics to do, and once you see the Zoom, you can finish those five topics. But again, don't wait until Monday night to do it, right? And then on Monday, I'll also continue on with the next chapter. I'll continue on with the next chapter, so make sure you have all of whatever you need ready with the worksheets. I'll put it on this. And next week, we'll have Group 8 present. Is Group 8 here by any chance? All right, I'll go ahead and put that on the announcement then. Does anyone have any questions?
Are you gonna post the video today?
Of this?
Yes.
Yeah, you know, the thing is with Zoom, it takes about a couple of hours after I close the conference Zoom for it to record for me. So that's why it takes me a while to post it up. But I will have it up by today. It just takes a little bit of time.
Yeah, I missed the first like 10-15 minutes, that's why.
Oh, okay. I'll try to put it up as soon as they send it to me.
Okay, thank you.
You're welcome.
And where would you like us to turn in our exam correction?
Oh, send it to me via Canvas.
Okay.
And the corrections are due by midnight tonight, Professor?
The corrections are due, ideally, I had said before the class starts, but that's fine if you can send it in to me tonight. Just make sure you write on the heading exam corrections.
Okay, thank you.
You're welcome. Any other questions?
For the SLAs, we have to do 5 in total, or how many in total?
We have to do 5 total before the end of the semester. So I've been giving you guys like mini deadlines to help you guys stay on track. So I think you guys should be at number 3 or 4, I forgot.
When is the next SLA due?
The next exam.
Oh, okay.
Oh, yeah, this one that's due today. But again, if you turn it in late, that's fine. Overall, you guys just need to have 5 of them done by the end of the semester. And I'm just giving you guys mini deadlines so that you guys don't get too far behind. But it's okay if you turn it in late, that's fine too.
Okay.
As far as like the group presentations, are they graded in with the student spotlight, or is it not graded at all?
Well, it's graded as a separate grade.
Okay, all right.
So you'll see by the end of the semester 1 grade for student spotlight and 1 grade for presentation.
Okay.
I have a question on number 5. I don't get the second part where you get x plus 1 and x minus 5.
Question number 5. You weren't sure how we got which one?
The second part, x plus 1 and x minus 5.
Okay. So here, number 5, x minus 1. I'm trying to find it. Where are you looking at? I'm sorry, which part?
Number 5. Question number 5.
Okay, number 5. Let me get to the right question. Okay. Oh, how we got this?
No, the bottom part says g over h equals x minus 1 slash x plus 1 x minus 5. It's the bottom part. I know how you got the answer. I just don't get how you got the formula.
Oh, x plus 1 x minus 5?
Yeah.
Got it. Oh, because the h is, because it's g divided by h, right?
Mhm.
So h is x minus x plus 1, x minus 5.
Okay, got it.
Yeah, because h is defined there.
Oh, okay, okay, I see. Okay.
Does that make sense?
Yeah.
Okay, good. Great question. I'm glad you asked.
Okay, thank you.
Any other questions?
I just want to send out a reminder about the Discord. If anyone needs help, I'm available noon to 4 Monday through Thursday. Gotten a couple people, but just remember, I'm there. And it's in chat right now if you want to copy that.
Thank you, Garrett.
Okay, thank you, Garrett. Yes, please utilize him and don't wait until last minute before an exam to utilize him. Anything today that you're like, what? How does she do that? Or if you, the last 5 sections I haven't taught yet, if you want to work ahead, you can ask him, hey, can you show me how to do those?
And this chapter, it looks like there's quite a bit of material in this chapter, so keep up with it. Don't wait till the last minute. Don't wait till Sunday night and message me when I'm studying for my own exams.
Right. How'd you do your exam, Garrett?
I think I did okay. Depends on how the rest of the class did because it's on a curve. So
Oh, it's on a curve? Oh,
as long
okay.
as I did, better than everyone else, I think I'm okay.
Garrett's a student as well, so just in case you guys forgot, he's studying for his own stuff.
And my finals are in a week.
Professor had a question. Is the final going to be cumulative of all the chapters?
So what I do is I take all the exams that you guys have already taken, and I take questions from that exam and put it on the final. So that's why I'm really big on making sure you guys correct your exams, because I don't want you guys to be at the end like trying to remember what you guys did, but you guys already have the corrections.
All right, thank you.
If you haven't noticed, a lot of the stuff that you learn in the past you're still using. Like you just solved an inequality, which was like chapters, in the beginning of the year or the semester, but we're still using it now. So it all builds on it, and math is going to continue to do that from here on out.
Good point. Any other thoughts or questions? Alrighty, it was great being with you guys. Good luck on your homework. I recommend take a small break, 30-minute break, and then from 1 to 4, work on Alex while it's still fresh in your mind. And then if you get stuck on something, hit up Garrett on Discord while he's on there between those 3 hours. So you won't be alone trying to work on something. All right, well, take care, you guys. I'll go ahead and stop the recording, and I'll see you guys on Monday. If you guys need to reach me, you know how to reach me on Facebook and on Canvas.
Thank you.
You're welcome.
Instructor, have a good afternoon.
You too.